For today's homework, we're going to be looking at the square root property, and we're going to be utilizing it to solve equations. So let's review the square root property. The square root property states that if you have a squared and it equals b, then when solving, a equals plus or minus b. You get two answers. So what are they really saying? They are saying that if you have a perfect square, like x squared, and it equals some number b, like let's just say 7, that when you solve, you can take the square root of both sides, okay? But you get two answers, a positive and a negative answer. And we know that when we take the square root of a perfect square, no matter what that perfect square is, right? Squaring means to multiply the same thing twice. We end up with a group of 2 that we can take out. So we end up with just x equals plus or minus the square root of 7. So knowing that when we take the square root of a perfect square, that the square actually just goes away, we're just going to make that assumption when we're solving these equations. So I think the biggest mistake that students make is that they forget to put the plus or minus sign when they are answering these questions. All right, so just as a heads up, it says the square root property implies that if you're solving an equation and you need to take the square roots of both sides of an equation to eliminate a square, you get two answers, a positive answer and a negative answer. So beware, that plus or minus is really, really important. You will get half credit off if you don't get two answers. So let's walk through a lot of the examples that are on the worksheet that I'm asking you to solve today. So here we have a perfect square, x squared, and it equals a number, and that's what you should check for. A perfect square that equals a number. Okay, a perfect square that equals a number. If you can get the equation in this form, then you can solve it using the square root property. So let's use the square root property to solve. So I have to get rid of the square, so I'm going to take the square root of both sides. And when I take the square root of both sides, I get plus or minus on one side. So now I know that taking the square root of a perfect square, the square goes away. How do I simplify 169? Well, I know 169 is 13 times 13, so I'm going to take out a group of 2, so I end up with x equals plus or minus 13. Don't forget the plus or minus. All right, next one. Well, here you notice that we don't have a perfect square that equals a number, but can we get it? Well, I think so. I think if we add 11 to both sides, we get x squared equals 11, and now we have that perfect square that equals a number. So we can use the square root property. So when we solve this, we're going to take the square root to get rid of the square, and we can't forget the plus or minus. 11 doesn't simplify. So really in this, all we have to do is take the square root of our square, and we're left with x equals plus or minus the square root of 11. All right, so here we don't have a perfect square that equals a number. We have this plus 100 on the side with our perfect square, so we're going to get rid of it by subtracting it to the other side. So now we have x squared equal negative 100. So we do have that perfect square that equals a number. So we're going to use the square root property to solve. So we're going to take the square root of x squared, and we're going to take the square root of negative 100. So this is where a couple lessons ago we learned about complex numbers. This is where we're going to get a complex solution, or maybe just a pure imaginary solution. When I take the square root of a perfect square, I just get the x itself. But now 100, let's see, how does 100 break up? I know that it's a negative 1 times 10 times 10. And one of the things I know about the square root of negative 1 is that this guy equals I. The square root of negative 1 is I. So I'm going to pull this 10 out, And I'm going to change the square root of -1 to I. And I almost forgot the plus or minus. It's really easy to forget that, so don't do that. Okay, so now again, we don't have a perfect square that equals a number. So what I'm going to do is I'm going to move the constant of -22 to the other side by adding it. And I get 2x squared equals 22. But I still don't have a perfect square that equals a number. I have this 2 in front. So I'm going to divide both sides by 2 to get rid of it. And I get x squared equals 11. This is much easier to solve now because now I have a nice perfect square that equals a number. All right, so we're going to use the square root property to solve that. And we're going to take the square root of x squared and take the square root of 11. And I'm not going to forget my plus or minus. 11 does not simplify, it's prime. So I end up with x equals plus or minus the square root of 11 as my answer. Okay, so I have 2 answers. Okay, how about this next example here? Do we have a perfect square that equals a number? Is that a perfect square? It's not. Okay, 10 is not a perfect square, so we will get rid of it and move it to the other side by dividing. So we end up with x squared equals 9 over 10. So in order to get rid of the square, we need to use the square root property because now we have a nice perfect square that equals a number. So we're going to take the square root of both sides. So I get the square root of x squared equals plus or minus, don't forget that. And remember, when you have fractions, you can separate your fraction into the numerator and denominator, taking the square root of each separately. So I know that 9 is a perfect square. It's 3 times 3. But 10 only gives me 2 times 5. So that's not going to simplify. So I know with this, I'm going to get a nice perfect square. I'm going to get 3 over the square root of 10. So when I take the square root of x squared, I get x equals plus or minus 3 over the square root of 10. But I also know that I'm not allowed to have radicals in my denominator. I have to rationalize. So I need a group of 2 10s, so I'm going to multiply by radical 10 over radical 10 to get x equals plus or minus 3 radical 10. You know, the denominator becomes the square root of 10 times 10, so that's going to simplify out to just 10. All right, so we're done with number 5. So let's move on to number 6. This is going to be a little bit more complicated, and these are a little bit harder to see. But doesn't matter what we are squaring, right? As long as this is a perfect square, and it is a perfect square because I have a parenthesis with a square on the outside. 14 is a number. I can use a square root property regardless. So I'm going to use the square root property to solve this. How am I going to do that? I'm going to set it down here. And I can't forget that plus or minus, that the square root property says that. And I know that 14 is just 2 times 7, so I don't have a group of 2 to simplify. So when I take the square root of something being squared, remember the square just goes away. So I get something that looks like this. All right, so I still have to solve this side right here. X is not by itself. But I have 2 answers on this side, positive and negative. So I'm going to set up 2 separate equations. I'm going to set it equal to the positive solution, and then I'm going to set it equal to the negative solution. And I'm going to solve both of them. Well, to get x by itself, I have to subtract 5 from both sides. So I get x equals, and we usually write the radical last, -5 and a positive radical 14 as one answer. And I'm going to subtract 5 from both sides again to get x equals -5 and a negative radical 14. So I get my 2 answers right here and box them in. All right, So here, again, we have a nice perfect square. There's nothing on the side with these parentheses. And this is a number. So I have a perfect square that equals a number. So I'm going to take the square root of both sides. And don't forget the plus or minus. I know 121 breaks down into 11 times 11. It's a perfect square. So when I take the square root of a square, the square just goes away along with the square root. So when I simplify plus or minus the square root of 121, it's plus or minus 11. So I need to break my equation into two equations to solve. So I get 2x minus 1 equals positive 11, and 2x minus 1 equals negative 11. So we're going to add 1 to both sides. So I get 2x equals 12. And when I divide by 2, I get x equals 6. Here on this one, when I add 1 to both sides, I get 2x equals negative 10. And when I divide by 2, I get x equals negative 5. So I get my two solutions right here. All right, next, I'm going to solve number 8. All right, so I have a perfect square that equals a number. Okay, so I'm going to use the square root property to solve. So I get the square root of 2x plus 3 squared equals, and don't forget the plus or minus, the square root of 10. 10 simplifies into 2 times 5. So there's no groups of 2, so it's just radical 10. And I know when I take the square root of a square, I just get whatever it is. So I have this. So again, I need to set up my two equations. I get 2x plus 3 equals positive square root of 10, and 2x plus 3 equals negative square root of 10. I'm going to subtract 3 from both sides, and I get 2x equals a negative 3 and a positive radical 10. I'm going to divide by 2, so I get x equals negative 3 plus radical 10 all over 2. And then on this one, I'm going to do the same thing. Subtract 3 from both sides. I get 2x equals negative 3 minus radical 10. And then I'm going to divide both sides by 2, and I get x equals negative 3 minus radical 10 all over 2. So I get two answers here. All right. Let's see if we can get two more examples done. Here I have a perfect square that equals a number. All right, so I'm going to use my square root property. 13 minus 19x squared equals plus or minus, don't forget that, 29's prime, so it's not going to factor. So I end up with 13 minus 19x equals plus or minus square root of 29. All right, I need to set up my two equations. Equals a positive square root of 29, and then 13 minus 19x equals a negative square root of 29. I'm going to go ahead and subtract the 13 from both sides, so I get a negative 19x equals negative 13 plus radical 29, and then I'm going to divide both sides by negative 19. All right, so now here we have a denominator with a negative in it, which we shouldn't keep. So we're going to go ahead and multiply by a negative 1 over a negative 1. So I need to distribute that negative 1, so it's going to change the signs. 13 is going to be positive, radical 29 is going to be negative, and negative 19 will be positive. All right, we're going to do the same here. We're going to subtract 13 from both sides to get negative 19x equals negative 13 minus radical 29. When I divide by a negative 19, I get x equals negative 13 minus radical 29 over negative 19. So again, I'm going to multiply by this negative 1 over negative 1, and excuse me, I just don't have enough room to actually do it. It's just going to change the sign of each of these to a positive. And now I have a positive 19 here, which looks really good. And I'm not going to have enough time to do the next one, but it's done the same way. We do have a perfect square that equals a number, so just take the square root of both sides and